When NASA's Mars Science Laboratory lands in a region known as Gale Crater in August of 2012, it will be poised to carry out the most sophisticated chemical analysis of the Martian surface to date. The minerals on Mars may reveal a chemical record of past and present environments, but the right tools are required to read this record. One of the 10 instruments on board the rover Curiosity will be CHEMIN, short for Chemistry and Mineralogy. Developed by Ames researcher David Blake and his team, it will use new technology to analyze and identify minerals in the Martian rocks and soil.
The measurement we're making is called powder X-ray diffraction, and it requires a powdered material, and quite often it's very difficult or impossible to powder a material finely enough to get a good pattern. We developed a method for shaking the grains at sonic frequencies that allows the grains to actually flow like a liquid through the beam, and when this is done, then all the crystals, as they go through the beam in random orientations, even though they're coarse-grained, have the appearance to the beam of being a fine-grained powder.
An X-ray beam no larger than a human hair will fire into the sample, causing the beam to scatter and also fluoresce the sample particles. A CCD sensor will capture the information so that it can be relayed to scientists back on Earth.
For planetary exploration, rather than trying to get a sample and bring it back to Earth, which is a very expensive and complicated procedure, we can now do laboratory quality analyses on the planet's surface in real time.
Different minerals are linked to certain kinds of environments. For example, some form with lava, some form with water. Scientists will use CHEMIN to search for mineral clues indicative of a past Martian environment that might have supported life. What makes it possible for Curiosity to carry this CHEMIN instrument is over 20 years of development by David Blake and his team. A device that once was the size of a double refrigerator has now been reduced to about the size of a briefcase. Variations of the instruments have been adapted for field work in geology, transportation security, and analysis of art and antiquities.